So in this video, we are going to be doing geometric series. So remember, series when you add the list of terms. The geometric sequence was just the list of them. So here is one way to write it. This is the way that I'm going to be using. Okay, so when we're in this, the a sub 1 is the first term. And it's the first term. The r is the ratio, or the rate you multiply by. N is your nth term. R is the ratio again. So notice it's 1 minus r in both of them, just 1/2 to the n power. Be careful because I will be putting that in parentheses. If you want to put it in for both, you can, but the top one, because it has an exponent, I'm always going to be using parentheses for that. Okay, so you cannot use the formula for the sum of the geometric series for which r is equal to 1 because dividing by 0 would result in a geometric series with r is equal to 1. The terms are constant. Therefore, the sum of an n term of a geometric series with r is equal to 1 is n times a to the first. Okay, you shouldn't have a rate of 1, basically. All right, so the other thing that's going to be key is we are going to have to use our sequence formula to find missing parts at one point. So just remembering that that's how we can find some missing parts. So it says find the sum of, so sum means we're using the S equation for it, of each geometric series given the following information. So here is my sum formula. Okay, so I'm just going to plug everything in. So my n is 15, so s of 15 is equal to my first term, 1 minus my rate to my n, divided by 1 minus my rate. So my Q that I'm using the sum formula is that S that's sitting there. And now I'm going to type in the top, divide by the bottom. So when I type in my top, I do 2, 1 minus 2 to the 15. So negative 65,500, 65534, divided by 1 minus 2 is negative 1. If you need to type it in your calculator, you can. Okay, and then if I divide those, I can do it in my calculator if you are bad at it. But that's what that is. So just remember when we are doing sums, the sum is if I added the whole list together. So if I go from a sub 1 and I have 15 terms, so my first one, I'm multiplying by 2, so 4. My next one would be 8, 16, 32, and there would be 15 of them. It's saying what is the sum of them. So what is it when I add them all up? That is why that number is so gigantic. It's the sum of that list. Okay, similarly, when we do our sigma notation, okay, it is right here is my sequence formula. So what are the things that I need to be able to make this equation? I need my first term, my rate, and my n. So my first term, I plug in the bottom again to find it. So 5 times 2 to the 1 minus 1. So if I go in here, 5 times 2 to the 1 minus 1. If you have the older calculator, you have to put your exponents in parentheses. So if you get the caret symbol and you don't actually get anything after, make sure that everything's in parentheses. Okay, generally it's the number that's sitting in front. That guy right there is going to most likely be your first term. Your rate is that 2. Just like when we have our exponential equations, that base that holds up the exponent is the rate we multiply by. So that 2 is going to be my r. And the only other thing is my n. So remember, we are going from 1 to 6. 1 to 6. So 1, 2, 3, 4, 5, 6. So my n is going to be a total of 6 terms. So s of 6 is equal to my first term, 1 minus my rate, to the 6th power, 1 minus the rate. So type in the top first, divide by your bottom. So 5 times 1 minus 2 to the 6th. And then it's going to be divided by 1 minus 2 is going to be negative 1 in this situation. So I'm going to get 315. Okay, so the next one, find the specific term of which each geometric series. So I've got a sub 1, that's what I'm trying to find. I'm trying to find my first term. So if I go into this, let's see if we can solve it. Because if not, then I have to go back to my sequence formula. So it says my sum, okay, so if I fill in S of 8 is equal to, I don't know my first term, my rate is 3, my N is now that 8, because remember, anytime you see that, they go in the same spot, 1 minus my rate. So is there anything else I can fill in? My S of 8, I haven't filled in yet my sum. All right, so then it's like, well, how do I solve it? Well, let's go ahead and do 1 minus 3. Let's figure out what all these numbers mean. So 1 minus 3, that's going to give me negative 2 here. Let's figure out what this is. So I'm going to do 1 minus 3 to the 8. I think that's what it was. Yep. Negative 6,560. Negative 6,000. 6560, all divided by. So now it's just, okay, I could divide that by negative 2. Okay, another option is I could multiply this negative 2 over to the other side to get rid of it. So 39360, 39360 times negative 2, negative 7,800. Oh, I missed a number. 39360 times negative 2. There, 78720. 78720. A sub 1 times negative 6560. Divide. So 12. So my first term is 12. Okay. So go ahead and try the next one on your own, and then I'm going to play back all of my work so that you can kind of see it. So it's going to be a similar process. You're missing a sub 1 again. You have your sum and you have your arc. So go ahead and try this one on your own and pause the video. Okay, so here is the final work for it. So go ahead and check your answer. Okay, just to clarify too, just in case, you do have to write sigma notation for any of them. Reminder that in the sigma notation is your sequence formula. So if you do have to write it, you'll just go into that formula to get him. You'll get this n is equal to 1 to your term number. It's going to work the exact same as how it did in the arithmetic series. But if for some reason you need to go into your sigma notation, I don't have a problem on here where you're doing it. You can go ahead and just use that sequence formula to get that, just like you did with your arithmetic one.